Sorry for the technical difficulties. Apparently my Mac doesn't work, shockingly, and I have to present from another laptop. The only difference is my demo won't work. I will explain the code, sorry for that. So we will work with what we have. Okay, welcome and thank you for coming. My talk is called Demystifying WebAssembly. My name is Andrei Cacio. I work at Mockups and I also contribute to JS Heroes. We do awesome meetups, so if you have some time, please come. You're mostly welcome. Before I continue with the purpose of my talk, who here heard of WebAssembly? Quite a bunch. Who uses WebAssembly? Okay, you might like my talk. I was going to ask who uses in production, but that ship has sailed. Oh, really? Nice, nice. Okay, so what's the purpose of my talk? When I first started learning WebAssembly, the technology was and is pretty new, and all the information was highly scattered all over the internet, and was from a JavaScript developer's point of view, coming from a front-end background, it was really painful. You didn't know exactly where to start, what you should learn, what WebAssembly is and how it can help you, and everything was such a mess that it was almost impossible just to get something working. So I guess after having a few small wins, I thought it was worth it to come here and present to you what I managed to do, and hopefully all the information will be much more simpler from my talk than you try to actually go and put things together and try to connect the dots. Again, WebAssembly is a low-level world, right? So coming from JavaScript code, it can be a really bumpy ride. So hopefully my presentation will be a starting point for anyone who wants to grab WebAssembly and get it spin. Okay, so what is WebAssembly? Well, WebAssembly is a new language that runs in the browser. But other than that, it's a compilation target. This means that you can have low-level code like C and C++, which you can compile it and run it in the browsers. This means that we will have new ways of writing applications, right? Right now we only have JavaScript that runs in the browser. Well, starting from now, we will be able to run other kinds of applications. Also, WebAssembly is a minimal viable product. This means that it will change. It is in continuous development, and what I'm about to show you may change in a few months or maybe even a year. It is really at its ground zero, right? Maybe what I'm about to show you may be a bit scary, but hopefully everything will get to a better place, to a better developer experience of using it. Okay, so why the need? Let's start with why do we need WebAssembly? Well, if we look at how JavaScript runs, JavaScript is a dynamic language, we all know that. What does this mean for the compiler? Well, for JavaScript to run fast and smooth, the compiler needs to do all sorts of black magic just to keep it running fast, just the way we like it. The compilation, all the parts in the compilation optimization of running JavaScript is a bit of, I won't call it a bottleneck because, well, it runs fast. But we can do better. We can optimize all this. So what does WebAssembly bring to the table? Well, WebAssembly, like I said, it's another language. But in contrast with JavaScript, WebAssembly is a static language. This means that, for example, in JavaScript we have all this dynamic calling. We can have dynamic arguments, dynamic function calling. We can create functions on the go. We can do all sorts of this, but for us it's fun, but for the compiler that's a pain because he doesn't know at compile time what will happen. He will always be surprised at runtime. Holy shit, that's a function, are you mad? So So with WebAssembly, the compiler will know upfront that everything the function, it will know all the signatures, all the types, all the arguments, what the function will return. And for him, it will be an easier process to compile all that. So in theory, this is where the performance boost will come. Okay, so we have low-level code, we have C and C++. Are there any C++ developers here, or a few? Okay, I hope you won't kill me. Of course, I presume most of you are JavaScript developers. Okay, so we have a new language. We have low-level stuff. Where do you even begin as a JavaScript developer to even touch all this, to get an understanding of why, or maybe why we should use it in the future? Well, let's start from the beginning. Let's presume we have a simple project structure, right? We have some C++ code, doesn't really matter. We have a compile tool. Again, for now, it doesn't matter what that tool is. The most important part is that that thing that outputs a WASM file. It is a simple file on your disk, right? But how should we imagine that file looks like, or how it works? For me, when I started running WebAssembly, I thought that I was seeing all these talks, right, at Google and all that big companies. They were saying that we have WebAssembly, we took a PK, compiled it, and run it in the browser. Yay! Well, how does that even work? I mean, is it a black box which magically runs? Well, not quite. For me, to get a better understanding, I thought, hey, let's think of it as an ES module, which kind of is. And what does ES module have? It has imports, it has exports. Like any other module, it may need something, some functions from outside, or it may export to you other functions for you to use to run that WebAssembly module. For now, don't put too much thought into this, just have a mental picture of it. Okay, so we have our WebAssembly module. We want to run it in the browser, right? Okay, just fine. We will need a simple HTTP server. We will get it through a GET request, and we will run it in the browser. We have three ways to compile it and parse it in the browser. We have the WebAssembly namespace, which offers one synchronous way and two asynchronous ways of doing it. Doesn't really matter right now. I will focus on the last API. So, okay, so let's see exactly how does this look. There's a nice tool called WebAssembly Studio. It is an online tool where you can actually don't bother with the compilation tooling. Like I said, for now it doesn't matter. You can actually write some low-level code and run it in a JavaScript application. On the left side, we will have some Rust code. Again, sorry for jumping right in. Don't worry about too much why we chose Rust. We will see a bit later. And on the left side, we have some JavaScript code. Okay, so let's see what happens here. Don't focus too much on the syntax right now. It doesn't matter. What matters is how they actually work, how they talk together, and how we can use them. Okay, so on the left side, we have some code, right? Let's focus on this one. Rust, being a low-level language, you can tell it, hey Rust, you might have some external functions. You can declare functions in it like any other language, but you can say, okay, this function, it looks like this. It has an integer argument, but you will get that the actual body of the function from somewhere outside. Don't worry about it, compile the code, use the function as you will, but that function will come from outside. Like I said, the WebAssembly module is like an ES module, you can import stuff. Well, think of this as the import statement. Okay, let's see on the left side, your right, I guess. Here we are using the WebAssembly instantiate streaming API. What that doesn't, don't focus too much on it. What actually does is you give it a fetch statement and the location of your WASM file. It fetches it, it compiles it, does all sorts of magic, and it spits out an instance. Right now it doesn't really matter. And the second argument, it's an import object. That import object lets us pass in functions to our WebAssembly module. Similar to Node.js, where we have that exports object, right? Okay. But how do we call functions from WebAssembly? Here we have this little thing, it's called a macro. Again, not really important. Think of it as an annotation. It takes your code and enhances it with all sorts of stuff. Why we need this is that, hey, we need to tell Rust that don't mingle with our function name at compile time. Leave it as is so we can call it from outside. Okay? And here we have a function that uses our external function called logInt. It logs a simple number. This unsafe part here, it only says that, hey Rust, it's an external function, it may break, we don't know, we don't control it. Just call it and let the developer deal with that. And the pub and extern part, it's simply saying that this is a public method from the module, and it will be called from somewhere outside, not necessarily from within Rust, okay? So, let's go back to JavaScript. This result will give us access to the actual instance of our WebAssembly module. If I uncomment this code right here, on the exports part, we will have access to all our functions from our WebAssembly module. So if I run this, we will see here all the functions from the left part of the code. For now, don't focus on the memory part. We will get to that a bit later. Okay? Okay, so let's run this function.log, see what happens. Okay, I'm commenting some code here. And when we run it, we will get 100. Amazing, right? 2018 programming. Okay. Let's do something interesting. Let's add two numbers, why not? Here we have a function that accepts two arguments, two integers, gives back an integer, and adds them. In Rust, there's a shortcut. You don't really have to type the return statement. You can only write the expression without the ending part, the punct și virgulă. Thank you. And it will return it automatically. It's a sugar code, nothing special. Okay. So I'm commenting this part, and let's add two numbers. Even more awesome, right? Okay. I can see your excitement. Okay, let's return a string. Let's see what happens. I know, hot. What do you think it will happen? We will get a string? We get a number. Awesome, right? I'm excited. Why do you get the number? Let's see. Surprise, surprise. WebAssembly knows to deal only with numbers. How awesome is that? It's fucking terrifying. That is what it is. When I started to learn WebAssembly, every example out there was adding two numbers or a Fibonacci function. That sucks because that works out of the box because WebAssembly deals only with numbers. But what if you want to try to pass in an object? Nobody tells you how. And you get insane, right? Because programming is fun. Okay. Also, in many talks, there are basically two examples. Adding two numbers or compiling a freaking game to the browser. But nobody talks the in-between part. How do they do that? Okay, so how do we pass non-numbers back and forth to WebAssembly? Well, it's the memory part, like which we saw on the next export statement. The memory is like any other application. WebAssembly needs to run in it needs a memory to use, right, to store stuff and all that. WebAssembly doesn't have access to our JavaScript memory. It won't access the DOM. It won't access all the global variables we declare. It doesn't have access to anything. It's kind of a closed sandbox. It doesn't have access to the computer's memory, or it won't read files from your computer. Don't worry about that. However, it has a kind of an array-like memory. Think about it as that, an array-ish memory, where it stores data in an array-like fashion, okay? That memory is exported from the WebAssembly module, so we can use it, so we can have a middle ground from JavaScript to WebAssembly, okay? So we can communicate in some way without actually calling functions or stuff like that. Okay, so let's see why did we get the number. That number was 1024, doesn't really matter, but what doesn't matter is what it represents. What do you think it represented?
Memory address.
Sorry?
Memory address.
Exactly.
We have
We have pointers in browsers. How fun is that? Yay! We can now kill ourselves. Okay. If you thought JavaScript was high level, well, think again. So what really happened? Well, WebAssembly took our string and it broke it down into each character, extracted the ASCII code, and stored it in its memory. So, like our friend here said, that number represented this, the exact location where our string starts in memory. Like I said, WebAssembly deals with numbers, so this is the only way you can transport a string through numbers. So, let's go back to our code and see how we can deal with that. Okay, coming down here, and then commenting some more code. Okay, so we have our getString function. We will store the value in a simple variable called startPoint, string startPoint. We will need the actual length because we can't we can't parse it dynamically, easily. And here we will have to use the memory. Okay? That memory returns that linear memory I was talking to you about. Why did I say it was an array-ish memory? Because it's actually a binary array. In JavaScript, we can deal with that with array buffers and typed arrays. Right now, it's not so important. What those actually do is deal with binary data, right? That data comes back as raw bytes of 0, 1, 0, 1s, okay? So, what we want to do is take a slice of our memory with just that string, nothing else. So, we create here an 8-byte array. What this special array does is hold in each index an 8-byte worth of data. Because ASCII codes can be represented in 8 bytes, that's enough for us. Don't stress it. It's not. Right now, it's only important for example. Okay, so what we are doing here is saying, hey, take our memory buffer. Here's the starting point. Here's the length. Make a slice of that memory. Okay. We store it here, and we can use a thing called a text decoder, which accepts an array buffer, typed array, sorry, and it will convert it to a string. So when we run this, we have our string. How easy was that? Okay. Objects. No, we don't want to talk about objects. Okay, for now, let's put that aside. Let's talk about tooling. That compiler I said, let's give it a name. Let's call it Mscripton. Mscripton is an open source tool which deals with compiling C++ code to WebAssembly. This is all nice, it does the job, it's really battle tested. But if you are a newbie like me and want to learn WebAssembly, it can be a pain because it's a huge project. Only if Pleasant, which all this stuff are gathered and documented very well, and they are pretty easy to take, read, and use. A big con to this approach is that it's pretty bleeding edge. It's really new stuff. You even need Rust in the beta version just to run it. And even this was enabled just a month ago, I think. Before that, you needed Rust in night mode just to run it. So I guess you can't say it's production ready, but just for learning WebAssembly and for our purpose, it does the job. Okay, let's look really quickly at Rust ecosystem. Similar to Node, we have Rust C, which is the compiler, not really important. We have a module system, a module manager called Cargo, similar to NPM. We have Rust Up, similar to NPM, which handles the versioning. Pretty simple, pretty familiar. But let's look at how Rust makes WebAssembly a bit easier to handle. Say we want to build a Rust library and use it in a JavaScript application, or we already have a JavaScript application and we want to use a Rust library. On the Rust part, we have a few tools. We have Cargo Generate, which generates a boilerplate project, just enough to get you started. We have WASM Bindgen, which is a library. I won't call it a framework, I don't think it's a framework, but it will help us not deal with memory in that awful fashion. And we have WASM, which you can think about it as similar to Webpack. It will handle all the building, all the compiling, just enough to give us an actual NPM module, which we can use in a project. On the JavaScript part, we have a Create WASM app, which is similar to Create React app if you use React. It's again a boilerplate tool. It generates a project just enough to handle WASM modules. We have NPM, we all know that, and we have Webpack 4. The interesting part of Webpack is that in Webpack 4 we have WebAssembly built in. Webpack knows how to load and use WebAssembly modules. This means that we won't have to deal with that WebAssembly API. We don't have to manually pass in all those import stuff. Right now, that code I showed you was really basic, but in reality, when you compile a Rust project, you will have to import a lot of other stuff, not just the functions you think you need. So it can be really painful just to do that by hand. Okay, I guess you want to see some more prettier code. Unfortunately, I can't show you the working part of the code, but I can show you the actual code. Let's see the JavaScript part. Okay, like I said, with the help of Cargo, with the help of WASM, we can handle the building and the compilation of the JavaScript, the Rust part of the code. What it will do, it will take our low-level code and spit out a package.json, a WASM file, and some JavaScript on top of that. So, in our JavaScript application, we will be able to npm link that module into our JavaScript application. So we will be able to do this. Plain and simple. Import that WASM module. Please ignore all the stuff here. I won't be able to show you, unfortunately. Let's see the Rust part. What basically my demo did, I had a paragraph and I wrote a function to fuzzy search in that paragraph, and it will highlight all the matches it found. Let's look at the Rust code. We have a different macro now. We have a WASM Bindgen macro. It basically, besides other stuff, it does what the non-macro did. It annotates it and it will use it for, it will tell Rust, hey, don't mangle the function, it will be exported, all that stuff. Also here, we can see we have two arguments. We have two strings, the query and the content. We will return another string. And here we simply do a dynamic regex, we create a regex, and we replace everything in the content with a hard-coded span and the matching part of the string. And then we return a copy of the string back to JavaScript. If we go back to JavaScript here, we can see this right here. No memory, just simple, give me that string. Why does it know to do this? Because like I said, WebAssembly, when it compiles our Rust code, it gives us enough JavaScript just to keep it running without us worrying about all that low-level stuff. So in the back, it basically does what we did in the WebAssembly Studio tool. It decodes it, reads memory, all that. Okay, but what if we want to pass in, let's say we have our fuzzy search WASM module. We want to have an array of books we want to filter, right? And also apply that pretty highlighting function. Books is simply JSON which I imported, nothing special there, it's an array of objects. But hey, look here, we are simply passing it to filter books without any memory handling whatsoever. Let's see on the Rust side what really happens. First, let's define our books, right? In Rust we don't have objects, we have structs, which is similar to objects. You can imagine them as so. We are telling here, hey Rust, we would like to have these books serializable, and we want to pass them outside of Rust in a different form, in the form of a JSON, right? So here we define our books as they have author, they have titles, both are strings. And we define a books struct, which basically holds a collection of an array, nothing special here. Okay, let's look at the filter books part. Don't worry too much about the syntax, let's focus on how we can deliver complex objects back. We have a JS value. This JS value right here can contain anything that comes from JavaScript. It can be any arbitrary data. But because we told Rust earlier, hey, we have these structs that you can use to serialize. So this way, Rust will know, hey, I can cast them back to books because he knows from the annotations. So now, that array we passed in from JavaScript, we can use it in Rust in its own native structures, data types, without any problems. Here, similar to JavaScript, we can iterate over it, we can iterate over our books, we can filter them. We then map that fuzzy function we wrote earlier, and we simply return a copy of our array back. Here, what this code does is serializing the array back to JSON and passing it back to JavaScript. So yeah, JSON is the magical solution. Of course, it has its drawbacks, but it will work more quickly than other alternatives. Sorry for the technical difficulties. I really wanted to show you the app, but thank you for listening to me and not walking out. You guys are awesome, and if you have any questions, all the resources are online. If you want to see the code, some more details and all that, you can access the GitHub link. And if you have any questions,
Are there any real-life applications other than add numbers and render a gaming browser at the moment?
Well, I only know really hardcore apps, like they ported AutoCAD to the browser. Maybe Ben told us that he uses in production, maybe he has some nice examples. But other than that, some more simpler examples I don't know to give you. But
I was just searching about 2 weeks ago, Transport Tycoon, if someone...
Even better.
And someone ported it and a lot of games from that company online. So if you are searching online for Transport Tycoon, you'll get to a Russian guy, and it has about 5 games at least compiled, and you can play on the browser, exactly with the old interface and things like that. So, yes.
Primary do have this crypto chain presentation, and the real life usage presented was some crypto kitties, Pokemon style stuff, and I was sitting there, okay, and
I don't know, some real case scenarios. I think if you have some heavy algorithms on your front end that deal with a lot of iterations or stuff like that, you can maybe port them. But I don't know to give you some real life examples, unfortunately. So,
maybe some more maths.
yeah. Sorry, there are some questions here.
Are there any benchmarks for how much Rust is faster in JavaScript or like filtering or searching?
Obviously, my examples won't be faster because I'm using the regex library, which JavaScript has natively built in the V8 or whatever engine it uses, so it won't be faster. But WebAssembly is faster in some scenarios and is slower in others. So if you're dealing with a lot of iterations, or if you are, I don't know, if you have an algorithm that needs an input and needs to give you an output, but inside it does a lot of heavy duty stuff like, I don't know, blockchains or image processing maybe even, there it will be faster. If you want to do a real-time image processing on a video feed, maybe WebAssembly will be faster. It should be. There isn't even a demo out there that shows this really example. But in, I don't know, adding a thing to a cart, it won't be faster. It has its scenarios and it doesn't have. It depends. Okay. Ben, you want to say something?
I think the most easy to understand example would be to all the crypto things you do to WebAssembly.
Yes.
So all the encryption, it really is cute to WebAssembly. You have all the libraries, and thanks to like it's 3 times faster, you can make 3 times as complicated whatsoever. So it's a really clear way.
Yeah. Any other questions? Yes?
Can you use WebAssembly in any browser?
Yes, WebAssembly, as far as I know, is integrated with Safari, Firefox, I think even Edge, if I'm not mistaken. The best part of WebAssembly is that all the browsers got on board and they actually fought really hard to bring it as compatible as possible. So I think today you can use it in any browser. Only the API I showed you earlier, the extension streaming API, I think that is in a draft state, so it's only used in, I think Safari didn't implemented it, but other than that, all the compile APIs I showed you earlier work. But again, WebAssembly is an MVP, it will continue to evolve, so they are working hard to make it backwards compatible, so that won't be a problem, but most probably a lot of things will change with time. Yes?
When do you think we'll have WebAssembly commonly used? We're working on projects, but not just planning the room.
Well, it needs a special use case to be worth it to use it. So I guess it depends on how complex projects will get in Cluj, or how complex are there, or I don't know. It has its own use case, its own scenario, so it won't be that, hey, let's put WebAssembly, why not? Like, hey, let's install React and WebAssembly, and I don't know, let's build a shopping cart. So, yeah, maybe it will take some time. Any other questions? Well then, really, thank you for coming, and I hope you like my talk.
Bună! Am ce s-a înfierbântat. Jesus!